Hey guys, welcome back. So today we're going to take a look at 11.2, the arithmetic sequences in series. So this is a particular type. It's a very common type. You should have hopefully seen it at some point in pre-algebra, algebra 1. If you didn't, this is nice. This will be it's still a simple lesson for you. If you did, it's a nice little review of the concept. So arithmetic sequences are ones where each number in the sequence is increasing or decreasing by the same value each time, where we call this value the common difference. We find a common difference, which we'll donate with the variable d. Very simply, it's just the second term minus the first term. So in this case, d equals a2 minus a1. So your equation, your main format is going to be, well, it's a linear equation actually. If you kind of recognize this is going to create linear steps here, and you can relate this back to your y equals mx plus b kind of stuff, that's exactly what this is right here, where the slope is the common difference, and then your coordinate points are based off the value of n, your first term, and all that. But in general, the explicit formula, an equals a1 plus n minus 1 times d. Very useful formula. We're going to use it a lot. So one way we can use it is I can give you the first couple terms in the sequence, and you can use that to write the explicit formula, and then use that to find a particular term. Because you don't necessarily want to just keep on going with the sequence, where we can clearly see d is a negative 5 because it's going down by 5s. And theoretically, you could just keep on going down by 5 until you get to the 18th term. While that would work, it would just be incredibly inefficient and not very helpful if I asked for, instead of the 18th term, but the 180th term instead. Then you're more likely to miscount somewhere or really mess it up. So writing the formula is very useful. So to do that, we need to know what d is in the first term, a1. So then we go to our formula, an equals a1 plus n minus 1 times d. And we go ahead and distribute and combine like terms. So our explicit formula would be negative 5n plus 12. Very straightforward. And then from there, if I want to find the 18th term, well, I just now fill in 18 for n. So negative 5 times 18 plus 12. And I find that the 18th term is a negative 78. So again, we're just filling into our very straightforward formula, a1 plus n minus 1 times d. And then once we write it out, we just fill in whatever they want. They want A18. The subscript tells us what the value of n is, and that's what we fill in for our question. So I can give you the first 4 terms and ask you that. I also could give you a term in the sequence, something later in there, and then the actual common difference. And you can use all that information to kind of work backwards. So this tells us right here that n is 25. So our formula an would be negative 2,402, because that's our 25th term, equals, we don't know the first term. We know n is 25, so it's 25 minus 1, and our d is negative 100. All we're doing, filling into the an equals a1 plus n minus 1 times d, format of your explicit formula. So this is our negative 2,402 equals a1. This comes out to be a negative 2,400. So that means a1 is a negative 2. Awesome. So if a1 is negative 2, we can now go back to our formula. We now leave an and n alone and fill in all the other stuff. Because the an and the n are essentially the x and y's of the problem, and we need to write our equation based on that information. So we get negative 2 minus 100n plus 100. So our explicit formula would have been negative 100n plus 98. And if we wanted to predict another term in the sequence, we would then just fill in the value for n and see, well, what's happening. All right, so those are pretty much your 2 standard questions where they want you to write the explicit form. Either they're going to give you a sequence of numbers, and you got to figure out the first term and common difference based on that sequence, or they're going to tell you what the common difference is and then a future term in the sequence. You're just going to have to figure out from there, okay, let's go work backwards, let's find a1, and then let's write our equation based off that. Now, you might also ask us to find missing terms, but here we're not going to need the equation because we can see that there are a first and last term there. So negative 8, and then we've got 4 missing terms, and then a 22. So the key to figure out what this value is going to be, we have to do the last term minus the first term, and then we have to divide by 1 more than the number of missing spaces. So we divide by 5. But if you think about this, we have to do plus d, plus d, plus d, plus d, and then plus d again to get to your last number. So that's why we're dividing by 5. So this gives us a 30 over 5, so that's 6. So that's really representing the common difference. So we're going up by 6s, so this should be -2, 4, 10, 16, and then 16 plus 6 is 22, so we do know that we fit the correct sequence. All right, so those are your basic questions involving the arithmetic sequence they might have to worry about. We also have the arithmetic series, and we might need to find a partial sum for the series because we can't find an infinite sum. If it's arithmetic, as we kind of saw in that one example from 11.1, infinite sums do not work because it diverges when the series is arithmetic based. So they're increasing or decreasing by the same number. Now for your partial sum formula, there's two formulas. The general formula, where you use A1 and AN, first term and last term in the sequence, is always going to be the partial sum Sn equals the number of terms n times the fraction A1 plus AN over 2. Now, an alternative formula for that, since we know an explicit formula for AN, you could fill in AN is A1 plus n minus 1 times D, and that gives us our alternate formula, where if I'm told the first term and the common difference, I want to find the sum of the first 100 terms, rather than trying to figure out what the 100th term is and then fill this formula out, we can just replace AN based off the explicit formula and use the alternative format right here. So again, whichever one we use, it depends entirely on what do they give us. So here we're noticing they're giving us the first and last term. They want to find the partial sum based on 10, so we want to find S10. So that's going to be our n times A1 plus AN all over 2. Now for this kind of problem, they might not tell you AN equals 133 and n equals 10. They might have just simply had said A10 equals 133. So then we know we're talking about the first 10 terms. So you go ahead and fill that out. The 10 over 2 is just simply a 5. 43 plus 133 is 176. And then multiplies to be 880. So for this particular series, based on the first term being 43, last term being 133, even though we don't know what the common difference is we can still figure out what the actual sum is going to be. Now in this scenario, they don't tell us the final term, they tell us how many terms there are, n is 13, and we're told the common difference is a 6. So this is our alternative format. So that's our n over 2, 2 times A1 plus n minus 1 times D. So we're just gonna leave that as 13 over 2. These kind of questions will typically be, as long as the first term is an integer and D is also an integer, it will be a nice integer value for the sum. Obviously, if there's decimals involved with A1 or D, then that's gonna obviously change. So we're not gonna write this as 13 over 2 as a decimal just yet. We're gonna leave it alone. We'll probably get an even number for the sum inside here. So 2 times 17 is 34. That's a 12 times 6, which is 72. So 13 over 2, this becomes a 106, which half of 106 is 53. And then 13 times 53 gives us 689 for our 13th partial sum. All right, so depending upon the question you get, those are your two ways you're going to find your partial sum. Pretty much you need to know what A1 is. So theoretically, even though I'm giving you this information, some of those other questions we had to kind of work backwards and figure what A1 was first. We could have done a partial sum based off that. So just pay attention to whatever they end up giving you in the setup for the question. Now finally, we could use a partial sum, be told what the partial sum is, and then find how many terms was in that sequence there. Noticing again, they're giving us first and last, so this would be our Sn equals n times A1 plus AN over 2. So here would be our Sn partial sum. We don't know what n is this time. 4 plus 76 over 2. So 4 plus 76 is 80, over 2 is a 40, and dividing the 40 over, we're going to get n to be 25. So for this scenario, there was 25 terms in this particular series. All right, so that's it for our arithmetic series. The next one we're going to talk about is geometric, which again, you probably, hopefully talked about in Algebra 1 or an Algebra 2 class. If not, this will be, again, still a relatively straightforward lesson, just kind of going through, again, different types of sequences and series. If you have done it, then it's a nice review, and that has its own set of benefits. So I'll see everyone next time.